Hi friends! According to numerous requests from the audience, I decided to start a cycle of training videos. I will try to make a video cycle the most colorful, comprehensible to people not related to electronics. I will try to bypass the difficult terminology and calculations. I hope that you will like the cycle and will support channel with your thumbs up. So, let's begin from resistor. At first view, resistor is simplest radio component, but it isn't. In simple words, the resistor is designed to limit the current in electric circuits. It isn't including active components in its construction. Resistor is passive component. Typically, in any electrical circuits, number of resistors is greater than the number of other components. Nevertheless, there are many different types of resistors. They can change their resistance depending on the different circumstances. Thermistors, changing their resistance depending on the temperature. Varistors, depending on the applied voltage. Photoresistors, depending on the light conditions. About each of these types we'll talk later. Now we will look at the classic resistor and its variants. Resistors could be fixed and variable. An ideal fixed resistor doesn't change its resistance. In opposite, variable resistors can change resistance depending on the temperature, pressure, light, or mechanical way. The last is a conventional trimmer, where the resistance can be changed manually by the movement of the slider. The main parameter of any resistor is the resistance in ohms. And as we know, if there is resistance, will be some heating. Resistors can limit current due to the fact that they dissipate part of the initial power as heat. Hence, the second parameter of the resistor is power. On the circuit diagrams, sometimes indicated power of the resistors. Depending on the different standards, they may look different, but there are plenty of tables which show the notation of resistors' power. They could be downloaded from the network. Resistors, as other passive components, may be connected in series and parallel. If connected in series, the total resistance of the chain equals the sum of the resistance of all the resistors. The number of resistors connected in series can be anyone, and the total resistance is always greater than the resistance of any single resistor. In parallel connection, the opposite occurs. We must sum the values inversely proportional to the resistances. For example, if three resistors 100 ohms connected in parallel, the total resistance calculated of the formula will be 33 ohms. This same formula used in the case for parallel connection of resistors with different resistance. It should be mentioned that in parallel connection will increase total power. For example, take the same three resistors of 100 ohms. The power of each separately is 0.25 watts. In the case of parallel connection, it will be summed and has 0.75 watts. This is often used when you haven't resistance of desired value. In parallel, you can connect any number of resistors, and the total resistance is always less than the resistance of any of the used resistors. The third parameter of the resistor is a tolerance, which shows percentage of deviation. In other words, shows how much the actual resistance of the resistor can deviate from the declared value. For example, take a standard 100 ohms resistor with a tolerance of 10%. Check its actual resistance with quite high precision multimeter. We see that there's some error, and judging by the labeling of the resistor, this error cannot be more than 10%. Take another resistor. The resistance again 100 ohms, but at accuracy of 1%. Measurement shows that this is much more accurate resistor than previous. There are resistors with an accuracy of a fraction of a percent, that called precision resistors, and used in high precision equipment, such as precision voltage and current sources, instrumentation, medical, military equipment, and so on. Rings of standard resistors shows everything you need to know. Usually at standard 4-lane marking, the color of the last ring of the resistor indicates the tolerance. The first two rings show resistance, and the third ring the multiplier. Each color strip is the code in the form of numbers from 0 to 9. You will learn to identify resistors by labeling over time. But in the meantime, I recommend using charts or specialized calculators to determine the labeling of resistors. In the description, you can find useful link. But resistors marking may be very different. Strips could be more or not to be at all. There are alphanumeric and other kinds of markings. But thanks to the internet, you can find an appropriate table or a calculator that will help you. And of course, the use of multimeter is essential. Resistors, as you already understand, limits the current flowing in the circuit, due to the fact that all the excess is converted into heat by the resistance. But this ability can be used to stabilize the voltage. Here is a simple circuit of parametric or linear regulator. In this circuit, after current limiting resistor is connected to the Zener diode that sets the fixed voltage, such as 12 volts. If you remove the resistor from the circuit, the Zener diode will burn because it isn't designed for high currents, and resistor provides the necessary current for the normal operation of the Zener diode. As you have guessed, at such a simple regulator, output current is too small. It isn't enough for high power loads. To solve this problem can be attached transistor as a current amplifier. Zener diode sets the voltage. Transistor will open as much as Zener allow. The load is already connected to transistor instead of Zener diode. Naturally, depending on the load power and the difference of the input and output voltage, the transistor will heat. So, modern linear regulators are supplemented with several cascaded transistor amplifiers, voltage switching systems, and other compensating nodes to provide a high efficiency and high stabilization of the output voltage. But that's another story. If the load, for example lead, isn't very powerful, it isn't necessary to stabilize the voltage, enough to limit the current. Lead has a certain glow voltage. That is, it will be in the role of the regulator and the load at the same time. So friends, I finished a general introduction, and in the following video we will deepen knowledge about resistors. We'll understand that is a resistive divider, how it works, consider the secondary parameters of resistors, their advantages and side effects, and much more. Because this is experimental video cycle, a big request to share it with your friends, as further production of training videos depends on their relevance and viewers. Now that's all. With you was Akakasyan. Bye, until we meet again.